Hello, this is Mr. Best. Welcome to Chapter 9, Homework Questions 68 through 74. Question 68. Examine the diagram of ABCD at the right. Part A. If opposite sides of the quadrilateral are parallel and all sides are congruent, what type of quadrilateral is ABCD? So once again, if opposite sides are parallel, so here and here, AD is parallel to BC, and CD is parallel to BA. And then also that all sides are congruent. So that means every single one of these sides would also be congruent as well. What type of quadrilateral must ABCD be? And the answer to that would be a rhombus. Because it has opposite sides that are parallel, and since all sides are congruent, it must be a rhombus. Part B, list what you know about the diagonals of ABCD. Since it's a rhombus, we know that the diagonals are perpendicular and intersect each other at their midpoints. And the other thing that could be mentioned is that they bisect the angles of the quadrilateral as well. All right, on to part C. Find the area of the rhombus ABCD if BC is equal to 8 and angle ABC is 60. So this angle right here is equal to 60. So what we can do, we need to figure out what the height of the rhombus is. So we'll create a right angle right here. If this is 60, then we know that this also creates a right angle. So this angle right in here would need to be 30 degrees. So we are looking at a 30, 60, 90. I'm going to redraw this so I can get a better kind of view of it. So this was 90, this angle right here would be 30, which means we're looking at a 30, 60, 90 triangle. We do know that the sides of the rhombus are 8, which would be this side right here. So that represents 8, so we can use our special triangle, or we can use our trig functions. So special right triangle, 30, 60, 90, the short side is half the hypotenuse, so that would be 4, and then the long side, which would be this one, is the square root of 3 times the short leg, which would be 4 square roots of 3. So that gives me the height of the rhombus, so therefore the area is base times height. So base is 8 times the height, which is 4 square roots of 3. So the area exactly would be 32 square roots of 3 units squared. And then if we approximated that, then the area would be approximately 55.4 units squared. Question 69. A butterfly house is at a local zoo as a rectangular prism with dimensions 20 feet by 15 feet by 10 feet and contains 625 butterflies. Sketch the prism on your paper. So I went ahead and sketched the prism. B, what is the volume of the butterfly house? So we want to find the base of the prism, which would be 15. The area of the base would be 15 times 10, so that's going to give us 150. And then to find the volume, we're going to take the base, and since there's 20 kind of levels of that, so we can take the 150 times the 20 levels, and that will give us a volume of 3,000 feet, but it'll be cubic feet. Part C, how many cubic feet of air is there for each butterfly? So for each butterfly we have, for the total, we have 3,000, and then there are 625 butterflies. So if we divide, that'll give us how much cubic feet of air is for each butterfly, and that will be 4.8 feet cubed. So that's how much air each butterfly will get. Question D, density is the quantity of something per unit measure, especially length, area, and volume. For example, you might talk about the density of birds on a power line, population density, or the mass density of an element. Assuming the butterflies are equally distributed inside the butterfly house, what is the density of the butterflies? So we want to find how much, once it says per unit measure, so we want to take the 625 butterflies and divide by the volume that we have, which is 3,000 feet cubed. So that will give us approximately 0.2 2, 1. And then how do we measure that? That'll be butterfly per cubic foot. So that's how many butterflies there would be on average per cubic foot. Question 70, use the relationship given in the diagram below to write and solve an equation for x. So we have two parallel lines. These angles right here would be alternate interior angles. So alternate interior angles are congruent. So therefore we should be able to write an equation where we set the values equal to each other, and then we're able to solve for x. I'm going to subtract 2x to both sides. And then I'm going to add 5 to both sides. Divide by 2. X is equal to 7. And that would be 7 degrees. Question 71, for each pair of triangles below, determine if the triangles are congruent. If they are congruent, state the congruency property that assures their congruency and write a congruency statement. So on part A, we have 62 degrees, one's 48 and one's 70. So let's go ahead and find the third angle for both of them. So all the angles are the same, which means that they're similar, but it doesn't mean they're congruent. So the line between 62 and 70, one of them is 9 and one of them is 8. Well, for them to be congruent, it has have that ratio of equal to 1. So on part A, these will not be congruent. These two triangles are not congruent. Because that ratio is not equal to 1. Part B, we have one big triangle and then two smaller ones. So this side length is congruent to itself, and we have a 90-degree angle here, which means we have a 90-degree angle here. And since we are dealing with a right triangle, all we need is a hypotenuse and a leg to prove that they are congruent. And here's the hypotenuse. AB and DB are the hypotenuse, and they're congruent. And then the reflexive property allows that side to be congruent to itself. So yes, they are congruent, and triangle ABC is congruent to triangle DBC. And we know that because the hypotenuse leg congruency. Part C, no angles are given, but we have a side length of 6 that matches with 6. We have a side of 8, and then a side of 9 and a side of 9. So therefore they are congruent. We can say triangle ACB is congruent to triangle KML, and make sure that you do have those in the right order. And we know they're congruent by side congruency. And as I said, make sure they're in the right order. I just realized that I didn't put them in the right order. So A matches up with K, but I went the wrong way. So if A goes to C, that's in between the 6 and the 9, so I got to go this way. So actually not K. A would be M, then K, then L. Question 72. Write the equation represented by the table below. So your x values are increasing by 1 each time. Your y values are increasing by 6 each time. So it's growing by 6. And you start at -2, so this would be y equals 6x minus 2. Question 73. This problem is a checkpoint for finding probabilities. Because students complained that there were not enough choices in the cafeteria, the student council decided to collect data about the sandwich choices that were available. The cafeteria supervisor indicated that she makes 36 sandwiches each day. Each sandwich consists of bread, protein, and a condiment. 12 of the sandwiches were made with white bread, 24 with whole grain bread. Half of the sandwiches were made with salami, and the other half were evenly split between turkey and ham. 2/3 of the sandwiches were made with mayonnaise, and the rest were left plain with no condiments. Part A, organize the possible sandwich combination of bread, protein, and condiment by making an area model or a tree diagram if possible. So, on the next slide here, I have the tree diagram. And so you can see that the bread you have white or grain, that was 1/3 to 2/3. And then the salami, turkey, and ham, salami was a half, turkey and ham were a fourth. And then from there the condiments was mayo or plain, and that was the difference of 2/3 and 1/3. And then at the very end here we have the probability of all 36 combinations. So that's part A. B, Wade likes any sandwich that has salami or mayonnaise on it. Which outcomes are sandwiches that Wade likes? If Wade randomly picks a sandwich, what is the probability that he will get a sandwich that he likes? You can use W and G to abbreviate the breads, then use S, T, and H to abbreviate the proteins, and M and P to abbreviate the condiments. So Wade is looking for a sandwich that has salami or mayonnaise on it. All right, let's look at all of these that have salami or mayonnaise. So here's salami, so it doesn't matter if it's mayo or plain. So these two, mayo, then mayo and mayo. So those are the ones we need to add up. So 2/18 plus 1/18. So 2/18, 1/18, 236. Another 2 out of 36. So that's these four. 4/18, 2/18, 4 out of 36, 4 out of 36. So that'd give you 30 out of 36, which is approximately 83.3%. So that's for part B with Wade. So we're just adding up all the possibilities where he has salami, or not and mayonnaise, but or mayonnaise. And that's why we have all these different combinations, because it's either salami or mayonnaise. Part C. Madison does not like salami or mayonnaise. Which outcomes are sandwiches that Madison likes? If Madison randomly picks a sandwich, what is the probability she will get a sandwich she likes? So whereas before, Wade wanted salami or mayonnaise, Madison does not. So what are the ones that don't have salami or mayonnaise? Well, these two are out. Turkey, no mayo, just plain. Ham, no mayo, just plain. So that's 136 plus 136. And then, once again, no salami. And then plain and plain. So we got 236 plus 136 and 136. And so you can see down here, if you add those up, you get 6 out of 36, which was 16.7%. And if you think, these two numbers are going to add up to 100 because one is salami or mayo, and the other one is salami or mayo, but not. It's the what is left. So that's why you get 16.7% there. And then on question, wrong way. And then on question D, if you have not already done so in part C, show how to use a complement to find the probability Madison gets a sandwich she likes, which is what I really just talked about. That you can take, the 100% that you start with, subtract the 83.3% because that's what Wade wanted, but that would leave us with the 16.7%, which is Madison, in terms of that's not the salami or the mayonnaise, so that's the complement. And then on part E, which outcomes are in the event for the intersection of salami and mayonnaise? And so then for part E, if we want, once again going back, we want the intersection, which is the and salami and mayonnaise, and we're just looking for the outcomes. So the outcomes would be white, salami, mayo. And then the other one would be grain, salami, and mayo. So there's only two that actually have salami and mayo. And so we should write these in our sets. Question 74, multiple choice. Which net below will not produce a closed cube? So if you have these four sides, if you just keep turning them over, that'll create the four sides, and this will be the top and the bottom. Same thing here, you'll get those four sides with the top and the bottom, and then same thing here, top and the bottom. But on B, you flip over these four sides, but they're going to be both on the same side here, so that's going to be a problem. So B is the net that will not produce a closed cube.